Hey, I'm Mike. Welcome to Need to Make It, and today we are testing and reviewing the Carvera Air, probably one of the most popular desktop CNC machines on the market, and also the most affordable. We're going to be running 3-axis parts. We are going to be running lots of 4-axis parts as well, which is one of the things that sets this machine apart from its competition. We're also going to be making lots of deep cuts. We're going to be making some mistakes along the way. And most importantly, we're going to be running materials I have not seen run on this machine before, all to find out what this machine is really capable of. So stick around, because this is probably one of the most detailed review videos of this machine on YouTube. So this is the Makera Carvera Air. It's one of 3 machines that they're offering now. There's the original Carvera, which has the fully automatic tool changer on the inside there. Pretty nice machine. A bigger machine, more expensive machine as well. This one here was the second one that they released. It's got a semi-automatic tool changer, a little bit smaller, but more affordable as well. And they also have a new one, which is called the Makera Z1, and it's, again, even more affordable, smaller, but it still has some features like the 4th axis that you can add to it to get that additional functionality. So first I want to take a look at all the features of this machine. 20mm rods, and you can see that we have bearings riding on those rods, so not bushings, so that means a long service life. I don't have any way of testing the hardness there, but I have to believe that these are hardened steel rods. For a machine to be accurate for a long period of time, and also for fast movement as well, we should have a ball screw setup. Yep, so you can see behind that stainless steel shield that we have a ball screw here, and it's got a nice beefy bearing that's holding that end in place as well, quite stiff. And it looks as though this is the type that's actually swaged or formed, so that should make for a very tough and long-lasting ball screw. And the further away the x-axis rods are from each other, the better. So they are 89mm apart, or 3.5 inches. So pretty decent distance apart. We have these EG15 linear rail carriages, pretty beefy linear rails also. And that means they are 15mm, and this is the depth by 10.74mm. It looks like the tops are ground. They look like they're hardened as well. And one thing that's hard to tell from this angle is that they have these really nice fitting squeegees on the top and on the bottom too. We have a thick aluminum plate. It is 12.37mm, almost 1/2 inch thick. And we have this handle here, which actually allows us to easily change the tools. And there's actually a probe down here as well to set our Z height for each tool that we're going to be changing out. So that does make that process quite a bit quicker. So we'll test this in a minute on a real part, but basically what we do, it's like a slot machine. You pull down the handle. It allows us to pull out the tool. In this case, this is just the placeholder for a tool. So this machine having the ability to do very precise work, look at the bits that you can put in here. Look how small that is. And then we can pull down that slot machine handle again. And that means we can load our new tool in. Nice. They have included a dust collection boot, and you can see here we have this rubber material. This actually looks maybe like vinyl that's connected to polycarbonate, and there's a magnet on the bottom so it easily snaps on and off. You can disconnect it, so if you want to use this hose and clean off your workpiece manually, you can do that too. This is more of a mounting position board, so they have all of these different threaded inserts in here. There's also some locating inserts inside there, so precision locating pins can go in here. If you're going to try and go all the way through, you definitely want to add a piece like this or something similar to this one. So this is one that they produce. This does look like MDF. The bottom one looks like high density fiberboard to me. And you can see we can just fasten directly through there. So for the bed, we have a little bit over 1/2 inch thick for the MDF. And then down below that, we have an 8mm thick aluminum plate, which is pretty close to 5/16 of an inch thick. And one very underrated feature of a CNC machine is how easy it is to keep clean. And look at what they've done here. They've actually taken this stainless steel plate and inset it into the frame. So it's perfectly flush. You can see there's no gap there either. So really nice job all the way around, keeping that really nice tight fit. So we have LED light on the inside pointed down at our workpiece, LED light on that side pointed down at the workpiece, a nice bright status bar on the outside of the machine, which is nice to see too. And you can see we have a gasket material all the way around here at the base. We also have these sealing strips here, just like you'd see on a window on the sides, but then you can also see it all the way around the top. So if we close this lid, it seals all of the way around here. So having the lid open versus lid closed makes a big difference in the sound level that's going to be exiting the machine that we're going to be able to hear in our shop. But it also is important for keeping the dust and any debris contained inside of the machine as well, and not getting into our shop. And I would say that's equally important with wood as it is with metal. With metal, you're going to get a lot of chips, which tend to be kind of sharp. You don't want those all over your floor. But with wood, you're going to get a lot of fine dust particles floating around in your shop. We have what looks like an injection molded aluminum base frame, and that base frame actually does connect vertically here with these pillars. I'm not sure if that's welded together or if it was injection molded as one big piece, but it comes right up the sides here. So our base frame actually connects to our X-axis as one piece, and then this is a steel powder coated shell which is connected to that frame. 20 millimeter again for the rods. We have the exact same ball screw setup as we saw on the X-axis. And up top here, which is connected to the bed, we have these pretty beefy extruded aluminum sections which are then machined, and that houses those linear bearings which ride on the rods. So overall, pretty robust construction, also made to be lightweight, which I'm sure is more for shipping reasons, but it also has a side benefit of being able to move this around easily in your own shop if you need to. Looks like you have the ability to have a pass-through, so you have more material that can be fed right into this machine. That's a really handy feature. You're going to be limited by this width, but I think it's a really good idea. And here we have a nice 24 volt Meanwell power supply, so a good quality power supply. This is a variable voltage as well, 100 to 120 volt, 200 to 240 volt. And the adjustment is actually just up above here. It is a little bit awkward to access on the inside, so I was able to reach in with my phone, see what it was set to, and then just switch it over. On the back here, where this gigantic aluminum heatsink is, this is the spindle control board. So this is specifically for the three-phase spindle. So we have the ability to have variable speed on that spindle. And here we have the main board, a little bit different than what I was expecting to see. I'm seeing only one traditional stepper motor driver. Now these are supposed to be closed loop stepper motors, so that could be the reason for that. Also nice to see that this electrical compartment is completely separate from the interior so that we don't get any dust or debris that is on the interior of the CNC machine getting in here and messing with any of the electronics. For anything that we're going to be plugging and unplugging all the time, we want to make sure that these connections stay solid, and they've done a good job with that. You can see here we have these nuts on the back side. They sandwich the steel plate between that nut and the flange here, so very solid connections there. And then in the case of the USB connections, we have a screwed connection. So in other words, these are going to stay solid for a very long time, no matter how much plugging and unplugging we do. And up top here, we have two connections. We have both a vacuum connection. So this is their vacuum. Makira makes this cyclonic vacuum. Got a nice filter in there as well. And that just connects right in here. Very tight fit. You want a vacuum that can generate high static pressure because this is a pretty small opening. And then here is a connection for your air supply. So if you have an air compressor you want to hook up, you can blow air either to clear your part, or you can blow it onto your cutter to cool your cutter as well. Anything that you're going to see machined in this video are from my designs, and that way we can experience problems that potentially other people have not run into with this machine. So this is a piece of 3mm thick cast acrylic, and I'm just using double-sided tape to secure it down to the spoil board. I've had good success with double-sided tape, and I've also had success with using glue gun as well. I like to use those options because then I have nothing coming up above the surface that I need to worry about my tools colliding with. But I will say that with this probe, I'm not sure it's that big of an issue because this probe not only probes height, and you can set the density that you want. So if you're running maybe a PCB and you want to account for any small undulations in the surface, you can set the probing density to be much higher than what I have set. And in addition to that, it also has a laser. So it's going to tell you exactly where your machining is going to occur. So that way you can make sure that you don't have anything that's not supposed to be there in the way. This came off of my other CNC machine. It came off really quickly, as you can see. This is not what it's supposed to look like. So I tried to make a 3D printed version. I mean, this works, but you're supposed to be able to see through it. Double-sided tape there, stuck nicely. Looks like the probing worked really well because we were able to get all the way through the part, and the spoil board is almost perfectly pristine. There's a little area right here where the bit looks like it was dwelling for a second, but other than that, it's in great shape. Looks perfect. I'm very happy with that. So I already know that this machine can do a good job with 3-axis parts. I've seen quite a few videos already on that subject. I don't really want to spend too much time focusing on that. What I'd like to focus on instead is how it does with the 4th axis. So let's get the 4th axis on and we'll machine some very intricate parts with it. So the install for the 4th axis was pretty easy. 2 pins for alignment, and then we bolt it down as well. There's a cable that plugs into one of 2 ports back there. Those ports also have caps on them, and those caps just make sure to keep the dust out over time, which is nice to see. So depending on the length of the part that you need to hold in here, you just loosen this knob. Tailstock is also on a bearing. It looks like quite a large bearing, which is nice to see. So that spins freely. And we can apply a little bit of tailstock pressure to make sure that our part is nice and secure. For the headstock, we have a harmonic drive inside of here. Harmonic drives are extremely precise. They don't have any backlash, basically 0. So that's very good when it comes to making highly precise and accurate parts. So with the 4-jaw chuck in here, it's kind of nice because if you're going to be holding square stock, it's much easier with a 4-jaw rather than with a 3-jaw. And these jaws are actually reversible as well. So they can come right out, flip around, so you have a lot of flexibility, whether you're holding from the inside or whether you want to hold from the outside as well. It should tell me with a line where my part is going to be machined approximately. Perfect. And it should come over and it should probe this top surface as well. That's going to get our Z height. So for the first tool, I'm just going to use this round nose cutter for our roughing passes. Now, if you notice my thumb is bleeding and a bunch of my other fingers are bleeding, it's because those bits are extremely sharp. I just brushed by one of the bits with my thumb and you can see it opened me up a little bit. So I have to be a little bit more careful next time. There we go. For my first 4-axis machining, this turned out great. I think it's time to move on to something that's a little bit more difficult, something that does not have a uniform grain, and that is wood. This is some hard maple that we took down locally. It just so happens to be the same thickness, or a little bit thicker than that epoxy. So I'm going to create a blank out of this. We'll get that mounted in the CNC and machine it. This has a Janka hardness of about 1450, so it's quite hard. I have one that is harder, a lot harder. This has about 3 times the hardness of that hard maple. So next, if that hard maple version goes well, we'll also machine this one. See here with the hard maple and the small diameter bits, as it's coming around here, there's a bit of bit flex, or the bit was dwelling in this area and it was able to dig in just a little bit. And I'm also just a little bit confused. The first one with the tailstock support was able to finish the top, but this one I removed the tailstock support and it has this strange flat section. Other than that, a pretty nice polished surface. So I think there's quite a bit of potential here. Now these are actually STL files that I generated. So I created an image and then I created a 3D model from that image. And then I was able to use that. So these are quite complex. They're not completely uniform. So basically this is the worst case scenario. Before I move on, I want to try another block of maple, exact same material, same size. And what I'm going to do is try to program from Fusion. So this will be my first attempt. And again, no tailstock support on this one. That is taking a fight. That's what I wanted. And it worked on the first go. The only issue that I ran into was at the very end, it continued to spin around like it did not end the program correctly. So I had to stop it manually, but other than that, it really worked great. Very impressed with the result. A little bit of fuzz there on the grain. The definition, or how fine I had the final pass coming along, wasn't set quite as fine as the previous one. You can see the previous one was nice and polished. This one's not quite as polished. This is meant to be cut off just manually, just so I had something beefy that I could hold on to that wouldn't vibrate. And other than that, it looks excellent. All of these edges nice and crisp. So since that works so well, I think it's time to move on to this. This is African blackwood. I think it's the 5th or 6th hardest wood on the planet. Janka hardness of somewhere around 3,500, between 3,500 and 4,000. So extremely, extremely dense material. It's also very abrasive material, and it also is something that I'm allergic to. You can see what it looks like on the end when I cut it with my table saw. It's nearly polished, extremely dense. You wouldn't even think that this is a piece of wood. stopped it because I thought it was going a bit too deep, but it actually seems like it's going to work. I just reacted. So I've never machined African blackwood before on a CNC machine. I've only machined it on my lathe, and I was using regular high-speed steel turning tools, and it was dulling those tools like crazy. But these bits, because they're carbide, do seem to be holding up pretty well. I will say that the African blackwood, when I was hogging off quite a bit of material, it did seem to be coming off in fairly large chunks, almost as if it was brittle. But now for the final pass here, you can see that it's quite smooth and kind of buttery almost, but definitely getting that polished look to it, which was kind of what I was hoping for. I bought this blanket about 10 years ago, and it was about $10 at that point. I'm assuming the price is much higher now. Wow, I really dug in pretty deep there, and I went back to Fusion to find out what I did wrong. Turns out I forgot to set the work coordinate system, or WCS, correctly. So I've corrected that. Hopefully this time it's going to work. First plunge is always the most difficult, and you can see I should have moved so that I actually start off of the part. That's what I had planned on doing. So this is a piece of bearing bronze, and I've had this for a long time. The whole purpose for having this was to make this exact piece that we're going to try and make right now. So this is extremely tough stuff. I've actually tried to cut this with a hacksaw. I had no luck at all with the hacksaw. It was just kind of skating along the surface, and I suppose that's probably also because it tends to be very low friction, but I was able to get through it pretty easily with an angle grinder. For whatever reason, even though I said to avoid the holes, because I have a path that does the hole specifically, it decided in Fusion that it was not going to avoid the hole, and all of a sudden plunged down in full depth. You can't see it on this side, but you can maybe see it there, right there. look at all this. Whoa. That's a lot of material. Holy cow. Oh, it looks like it's gonna work. Let's have a look. Oh, ho, ho, look at that. I double checked the shaft size. We're slightly under what I was hoping for. It's 0.04 millimeters under. So very, very close. I think this will still work perfectly fine. I do need to tap the inside here. It's a left-hand Acme thread to match this one that's all worn out, and just cut this off and we are good. So this is actually going to become a usable part. So what you saw here was actually true 4-axis machining. And the reason for that is because we have, of course, our X, we have our Z, our up and down. We have our A, which is the rotational axis, but then the Y-axis, you could see there when we were doing the flats and we were doing the holes, it was moving the Y-axis back and forth. And that's important because without that, we don't have the ability to do all of these surfaces. So that would be my only one complaint with the software that you can program this machine with, is that it doesn't give you a lot of flexibility when it comes to 4-axis programming, whereas Fusion does do that. I had a look on their website and it looks like they have a new version of the software that's coming out. I'm just trying to find out exactly when that's happening, but that'll be interesting to see whether it includes features like that to give that type of flexibility. So area for improvement up here. This clip, if this hose is going to come in and out, at least to use to vacuum the interior, some of these edges are extremely sharp and I noticed that it's starting to wear down a little bit on this tube. You can see, hopefully you can see there, there's some marks. So I'm just going to do that manually with a little file. The front edge is rounded, but the back edge is completely sharp. The tool changer works great. Very happy with that. Super quick, definitely way better than trying to use a wrench. And the fact that they have the tool setter in there also just makes that whole process of changing tools way quicker. The beep will tell you when you need to change the tool, and that's really all that you need to pay attention to. The connection for the air compressor at the back is quite small, so I didn't have the ability to connect my air compressor to try this out, but it should work just fine. My only complaint would be the position. I think it probably should be towards the front, blowing towards the back of the machine, and that way all of this stuff would accumulate towards the back, because if you look here, even though I didn't have it on, all of this, as soon as you open it up, it's going to try and spill out. And you don't really want this on your table, and it's going to eventually get onto the floor as well. And they are really, really sharp. They're going to get right into your feet. They're going to get right into your shoes and into your fingers if you're touching them. So it's better if you can try and send everything towards the back and just clean it up from there with a vacuum. I didn't pay too much attention to it earlier, but there are covers over most everything on the inside here. We did look at the stainless steel, but there are also other plastic covers. And that's really good because after seeing all these metal particles go everywhere, they are literally everywhere inside of this machine. Having those covers on here is important to keep the metal off of any sensitive areas. I was probably hocking off more material than I should have, and when I was doing that, I noticed the machine vibrating a little bit. You can actually see some of the chips kind of dancing around. But when I was doing the finish passes, I didn't notice that, so I think that's absolutely fine. These were all 1/8 inch diameter bits for the shaft, and you can replace the complete collet on the inside there. So this is for 6mm. Unfortunately, I don't have any 6mm, I only have 1/4 inch, but there is a 1/4 inch option as well. So basically you can use 1/4 inch, 6mm, 4mm, and 1/8 inch, and also 3mm. So quite a variety of different size diameter shanks that you can get in here. Now we could see with this bit, because there was so much stick out here when I was doing the machining for these holes, these are quite deep, that it was jumping around quite a bit. So it's good that you've got a variety, because I think for the most part I would probably stick with 6mm bits unless I'm doing extremely precise work. I was using this machine from my laptop for both programming and for the controller as well, and I was doing that wirelessly. You can mount a phone or you can mount a tablet here, and you can operate the machine directly from here wirelessly, or you can connect with a cable to the back of the machine and have a wired connection as well. So overall, pretty impressive machine. There's definitely a lot to like about what they've done here. So this machine is actually on sale right now. I will leave links below just so you can get the current pricing, but right now it is $2,499 US. That's for the base unit. You can also get different bundles, but the one I would recommend the most would be with the 4th axis. That is $2,898 to have that bundled together. So thank you to Make Here for setting this machine for me to test out. I definitely used and abused the machine, and I made a few mistakes along the way, but it actually performed better than what I was expecting. So I have no problem recommending this machine. I'd also like to thank my patrons for helping to make videos like this one possible, and thank you for watching. Take care, and hope to see you on the next one.